Structure of atmosphere basically refers to exactly how different layers are arranged. So, as you may be knowing that this atmosphere is attached to the earth because of the gravity. It is like an envelope around the earth. So the classification of structure will depend upon what criteria we take, because every classification depends upon the criteria. For example, if you want to classify this caste based upon different criteria, then the same class can be classified in different manner. For example, if you classify this class on the basis of the religion, then this in this class some may be Hindu, some may be Muslim, some may be Sikh, some may be Christians. The same class, if you classify on the basis of different criteria, for example, if you classify the same class on the basis of the ages, then some may be between 20 to 25, some may be from 25 to 30. So whenever you change the criteria, then the classification also can get changed. So the same thing we have to study here in the structure of the atmosphere. Whenever we will discuss the structure of the atmosphere, then the first thing that you should know is that on what basis we are classifying the structure. For example, if you classify the structure on the basis of composition, then you have a different classification. You can classify the structure into two zones, which is one is called as homosphere, another called as homosphere, another called as heterosphere. Heterosphere. So, if you classify the atmosphere on the basis of the composition, then you have a two different zone, that is one is homosphere, another is called as heterosphere. Why this area up till some height, this area is called as homosphere? Because in this part of the atmosphere, the composition of the atmosphere remains the same everywhere. uh, for example, if you take the sample of air from New York and the another sample from the Mumbai or from Delhi, then you will find that the proportion of the gases will remain almost the same. Like if you have a 78% of nitrogen, if you have a 20% of oxygen, then in all the samples the proportion of these gases will remain the same. So that's why it is called as homosphere. Why actually the proportion of the gases remains the same? Because in this part of the atmosphere, because of the churning, because of the convection, the mixing keep on taking place in this part. That is the reason why the proportion of the gases remains the same regardless of from wherever you may have taken the sample. So but after this height, because in this part there is no churning taking place, that's why the gases get themselves arranged according to their molecular weight. So the lightest gas will be on the top and the heaviest gas will be on the bottom of this zone. So because in this part there is no mixing taking place, that's why these gases get themselves arranged according to their molecular weight. So that's why this part is known as heterosphere. This classification is based upon the composition. When we change our criteria, then if we classify the same atmosphere on the basis of how exactly with the height the temperature keep on increasing or it keep on decreasing, then you have a different classification. Then you have a troposphere, then you have a again you have a stratosphere, then you have a mesosphere, then you have a thermosphere. So this is height, and here you have on this axis you have a temperature. So this is a troposphere, this is again you have a stratosphere, then you have a mesosphere, and then you have a thermosphere. So in the troposphere the temperature with the will keep on decreasing with the height, because of the fact that the main source of the heating of the atmosphere is the earth, not the sun. That's why as you move away from the source of the heating, then the temperature will keep on getting decrease. And the other reason why exactly the temperature keep on getting decreased with the height is because of the fact that the most of the gases which is responsible for trapping the long wave radiation radiated by the earth's surface is found closer to the earth's surface, like for example water vapor and carbon dioxide. As you move up in the atmosphere, then the atmosphere also becomes rare and rare with the height. So that's why the temperature will keep on decreasing till the tropopause. These pause are nothing but the transitional layer between different spheres. In the stratosphere again the temperature will start increasing because of the presence of ozone in this part. This ozone is responsible for absorbing the ultraviolet rays coming from the sun. So that's why in this part the temperature will keep on getting increased with the height. Then again in the mesosphere again the temperature will start decreasing throughout the mesosphere, because there is no ozone present in the mesosphere and it is away from the heating source of the atmosphere, that is the earth. So that's why throughout the mesosphere the temperature will keep on getting decreased. Again in thermosphere the temperature will start rising. Why? Because this part is very close to the sun. So theoretically the temperature in this part is very high, theoretically. But if you go to this area, if you go to this part of the atmosphere, then you will not be able to experience this temperature, because the temperature, the atmosphere becomes so rare in this part that hardly you can feel the, you can experience the high temperature. Because whenever actually how you experience the temperature, because wherever the atmosphere is dense, then thousands of gas particles keep on hitting your body. That's how you experience the temperature. But when in this part the temperature becomes so rare that you hardly can feel the temperature in this part. But these gases remain here in atomic state, so that's why they are not able to radiate back the energy that they are actually absorbing. So these gases are not able to radiate this energy back. That's why the temperature of this part becomes very high. So this is another classification based upon the how exactly the temperature with the height actually uh, varies. Then you have if you take the ionization as a criteria, if you take the ionization as a criteria, then you have another classification, that is ionosphere, you can say. That is ionosphere and non-ionosphere, you can say. So in this part, because this part is very close to the sun, that's why the gases, the atoms of the gases get themselves converted into ions. Because of the solar energy, these atoms lose one electron, and that's how they become charged, they become ions. So there are many layers of ions in this part. There are many layers of the ions in this part of this atmosphere. These layers are also has been responsible for the transmission that we have on the earth surface. That is a uh, radio waves are, this is especially, this layer is known as E layer, which has been responsible for this radio transmission that we have on the surface, because these radio waves are actually transmitted from the radio stations, and this again get reflected by this E layer, and this it can be received on the transistor. So that's how we actually receive these radio waves in our transistor. So that's why these layers are, this layer of ions is responsible for this transmission that we have on the earth's surface. But in the, you may have observed that in the evening, in the night, earlier the transmission became used to become very clear. This was because of the fact that, you know, in the daytime, because the more amount of energy is available, that's why till this depth many more ionic layer get themselves developed. But in the night time, when the energy is availability is less, then these layers actually become absent in the night time, and that's why we receive better transmission in the night time, because whenever these radio waves passes through these ionic layer, then lot of energy get dissipated. That's why in the daytime we didn't have the kind of transmission, the better transmission that we have had actually in the night time. So that's why this is based upon the ionization. You can classify the atmosphere on the basis of ionization also. Then on the basis of the chemical reaction also, you can classify the atmosphere into two: chemosphere and non-chemosphere. So chemosphere is a part of atmosphere where actually the chemical reaction takes place, because here actually ozone is formed in the chemosphere. So because of solar energy, is O2 get split into O plus O, and then again another O2 will combine with this O, that will lead to the formation of O3. So in this part of this atmosphere, because of the solar energy, a lot of chemical reaction keep on taking place. That's why it is known as chemosphere. And this is part, you can consider it as a non-chemosphere, because here the availability of energy is very less. That's why there will be no chemical reaction taking place in this part. So ozone is formed in the chemosphere, and after having been formed, it start getting settled into the stratosphere. So that's how you can classify on the basis of different criteria. You can classify the atmospheric structure. So whenever if you are asked to classify the structure, the first thing that you should be asking is that on the basis of which criteria, because if you change the criteria, then your classification also will be changed. If you classify the structure of atmosphere on the basis of the composition, then you have a homosphere and heterosphere. If you classify on the basis of how exactly the temperature varies with the height, then your classification will be troposphere, stratosphere, mesosphere and thermosphere. On the basis of ionization, you can also classify the atmosphere into non-chemosphere and chemosphere. And on the basis of chemical reaction also, you can classify the atmosphere into two part, that is chemosphere and non-chemosphere.